we are discussing about the unit kinematics, and in kinematics we are discussing about the graphs, right? So graphical representation we have done in the previous class. Let's see the next one, graphical representation. Can you able to see this or not?
Yes, sir, we can.
Oh, you can see, right? I'll just put it here. Yeah, so the graphical representation of VT graph. VT graph. What is VT graph here? What does it mean? VT means what? Velocity time graph. Okay, so we have different graphs here in the velocity time graph. So we discuss about what is velocity time graph here. I'll just show one diagram here first so that you can understand. We take velocity in the y-axis and time in the x-axis. Okay, so this kind of a graph, if you get, this is called VT graph, velocity time graph. And here velocity, what is velocity, right? How can you define velocity? Yes, can you tell me, anyone? How can you define velocity? What is velocity? Yes.
Velocity is equal to displacement by time.
Yeah, displacement by time. So we take here displacement by time. Displacement by time we take. Right, very good. So displacement, right, is measured in distance per, that is s by t, that is v equal to s by t. So we write the formula as v equal to s by t. What is s here? S displacement, t is time. So we measure in meter per second, right? So meter per second is the units we have. So generally we write as ms per minus 1. So this is the units we measure for velocity. And in velocity we also have uniform velocity as well as non-uniform velocity. For uniform velocity, what happens? The object covers equal velocity takes place in equal interval of time. So constant velocity also you can say. What is constant velocity? If it maintains the velocity constant, that doesn't change its velocity with respect to time. For example, any object traveling with 50 kilometer per hour, it will maintain that speed. Neither it increases, neither it will decreases. It will remain the constant speed. So any object which maintains the same speed, okay, so we call them as constant speed. If it increases or decreases, then what happens? The velocity term will be changes to another one that is called as acceleration. You know about acceleration, right? So increase in the velocity with respect to time and decrease in the velocity with respect to time. So acceleration we say as increase in the velocity with respect to time, that is called acceleration. And decrease in the velocity with respect to time, that is called deceleration. So we have the other two terms that we are using here, acceleration as well as deceleration. So acceleration is what? An increase in the velocity with respect to time. For example, you're started from a station in the railway station. You started from a station and you're just about to move in the from that station. So the speed of the vehicle, or we can say the train, continuously increases from 10, 20, 30, like this goes on from zero. Why? Because it is stationary train it is. So from there 0 to 10, 20, 30, like this goes on, increases till 100. So let us take 100 is a meter per second. It has 100 kilometer per hour is traveling. So what happens from starting onwards? That is from 0, 10, 20, 30. What happens? It has picked up the speed. So it increases the speed here. So in this case, we say the train is moving with acceleration. What happens in the acceleration? Increase in the velocity with respect to time is called acceleration. So here the train started from initially from zero and then started and now continuously moving up and speeding up the velocity. So like this, it continuously speeds up the velocity. So this is called acceleration. So acceleration is increase in the velocity with respect to time. It's called acceleration. Now let's talk about the deceleration, because this term we're going to use again here, and we're going to check in the graphs also. So these basic things we must know before heading to the graphs. So let's talk about the next one, that is deceleration. What is deceleration? What happens in the deceleration? Can you tell me what happens in the deceleration? Decrease in the velocity, right? So velocity will be decreases. So decrease in the velocity with respect to time, that is called deceleration. For example, now the station, from the station the train has started and it has picked up the speed up to 100 kilometers per hour. Okay, that's good. Now the same train now approaching the nearby station. Now it cannot move with the same speed, right? So the driver of the train has to decrease the speed. So, obviously, what he will do, he will decrease the speed continuously. From 100, he will go down to 90, 80, 70, 40, like this goes on till the station reaches. He has to decrease the speed, and acceleration has to become zero. So when you get the speed becomes zero, when the velocity becomes zero, then what happens? Okay, when the velocity becomes zero, the time here, when the velocity becomes zero, what happens? The time when the velocity becomes zero, that is what you call acceleration will be equal to zero. So the velocity of the object will be decreases so that it becomes zero. Till it becomes zero, it will continuously decrease the speed. So decrease in the velocity with respect to time, that is called deceleration. And deceleration is also called as retardation. Okay, what is another name for this? It is also called as retardation. Retardation. It's also called as retardation, or it's also called as negative acceleration. Okay, negative acceleration. Okay, this is another name for this. We have another one that is also called as deceleration. Okay, so this is the different terms we use for deceleration. It is also called as retardation, negative acceleration, or deceleration. All the three names we just give for the negative acceleration. That is a deceleration. Okay, so deceleration means decrease in the velocity with respect to time. That is called deceleration. Now let's talk about the next one. We have the next one, that is we say formula. If you talk about the formula acceleration, we say that the final velocity we just subtract with the initial velocity with respect to time. So this is acceleration. So the formula of acceleration is we just take the final velocity. Okay, let us take here, this is the object which is moving from one end to other end. It is having u, this is having v. It's moved with respect to time t. Okay, in unit time t, it has made a displacement s. Okay, with moving with acceleration a. So initial point, this is a final point. So initial velocity, this is a final velocity. So what we do means in the acceleration, we just take final velocity, we just subtract with the initial velocity with respect to time. Why we're taking like this? Because acceleration is nothing more is a change in velocity. So here v minus u is a change in velocity. Okay, so v minus u is a change in velocity. So that's why we take final velocity minus initial velocity, that will be divided by time, that is nothing but acceleration. So change in velocity with respect to time, that is acceleration, can be seen here. So this is the formula we generally use for acceleration. And now if you talk about acceleration, just now I said velocity by time, so we take velocity units. What is the velocity units? That is meter per second. Okay, and time is also measured in second. So this we take one like this will be converted to meter per second and 1 by second. Just reciprocal this, we get meter per second square. So generally we use meter per second square is the units which is used to measure for acceleration. So acceleration is measured in meter per second. Okay, meter per second square. Acceleration is measured in meter per second square is the unit we use. A equal to meter per second square is the unit we use for acceleration. Is it clear? Right. Yeah. Any questions you have here? You can ask me.
No, sir.
Yeah, that's the thing. This is a very simple topic. Here we have acceleration, right? So in this way, we measure the units of acceleration. And you can see the formula, v minus u by t. Why we take v minus u, I told you. What is that reason? Because the change in velocity is always represented by v minus u. So final velocity minus initial velocity is a change in velocity. Okay, with respect to time. So a equal to v by t, units is meter per second square. So this is acceleration. And if you talk about the deceleration, well, the units will be same, but it is a negative symbol we put. Okay, whatever the value we take, we just put it in the negative symbol. For example, if you apply a brake, that also a negative acceleration, that is deceleration. You are applying the brakes in the vehicle, it's a negative acceleration. Okay, right. So this is opposing, decreasing the velocity there. Okay, one more example. Let us take, if you take an object and throw it in the air, what happens? The object will move at a certain distance. Okay, like you throw the ball in the air, what happens? It will move at a certain distance and then it will stop there. Again, it will come back to the ground. Right, so the maximum velocity will reach, then it will come back to the ground. Right, so that is also a deceleration, because as the object move up in the direction, the velocity goes on decreasing. So when it decreases the velocity, that's it becomes zero and then come back to the ground. So the object which is moving in the upward direction is actually decelerating. So we can say it's a decelerating object. When it's moved at a certain height, maximum height, once it reach, then it come back ground to the ground again. Right. So when it's coming down, then again it is acceleration, because velocity will be continuously increases because of the gravity, because gravitation force is acting on the object. So because of that, what happens? It goes on increasing the velocity. Okay, and when it moves up, the velocity will be go on decreases, that is called deceleration. When it moves down, that it is moving with acceleration. So there's a two difference we can say. Object moving up, deceleration. When the object moves down, that is acceleration. So acceleration, deceleration can be seen in a single example. When you throw the object, decelerate. When it comes down, that is acceleration. Okay, so acceleration and deceleration we can say. And one more thing we can say here, we can add up, that is called uniform accelerated motion. So the object which is coming down, it is actually moving with uniform accelerated motion. Like here, its velocity is up to here, it is different, up to here it is different. At this part it is maximum, the velocity is maximum at this part. So continuously keep on increasing the velocity. That's that kind of a velocity we call as uniform accelerated motion. Continuously it increases the velocity here. So this velocity here is called, this acceleration is called here uniform accelerated motion. Because of the gravitation pull, it will be continuously increasing the velocity. The velocity will be here at this point, it is different at this point, and it is maximum when it touches the ground. So the velocity will be maximum when it touches the ground. Okay, so that is uniform accelerated motion, we can say. This motion here is called uniform accelerated motion. And it is also called as acceleration due to gravity. And we generally represent with g. G is called acceleration due to gravity. A freely falling object which is falling due to the gravitation pull of the earth, that is called acceleration due to gravity. So a here we just represent with g. So the g will be positive or the g will be negative. So g will be positive if the object is moving towards the ground. Okay, if g will be negative if the object is trying to move up in the direction. So this thing you can remember. So positive g, negative g also we get. Positive g means it is when it is moving towards the gravity. So the gravitation pull in the downward direction. So this and this are same, but this is against the gravity. Okay, the arrow you can see, arrow is against, but here this is pulling towards the gravity. Okay, so this arrow and this arrow are different. So this is against the gravity, and this is moving, pulling the objects in the downward direction. So if it is against the gravity, we put the negative sign, that is deceleration. And here if we putting towards the gravity, that is we put positive g, that is positive acceleration, and this is negative acceleration. So this will discuss in the another chapter we have, that we will discuss that. Just I'm trying to explain about what is called acceleration. And acceleration due to gravity is different. Okay, because it's because of the pulling of the earth, that we study in the separate topic. Okay, so acceleration and deceleration we have done. And uniform, this object is moving with uniform accelerated motion. If it is going up, uniform deaccelerated motion we can say. Uniform deaccelerated motion when it is move up. Okay, when it's moving down, uniform accelerated motion. Okay, now, so we understood about acceleration, deceleration, velocity, units, everything we have understood. Now, if we talk about the different units which we have discussed till now, we measure distance, that is S. Distance is measured in where? Distance S is measured in meters. Displacement is also measured in meters. Okay, velocity, that is V, that is speed, we can say. Speed is measured in meter per second. Okay, and velocity, okay, is a vector quantity. This is also measured in meter per second. See, the arrowhead indicates that is a vector quantity. Okay, here arrowhead indicates that's a vector quantity. So this is, I'm talking about velocity. Okay, and this is, I'm talking about speed. That's the difference. Here this is displacement. Okay, and what is this? This is distance. Okay, displacement is a vector quantity, so I put the arrowhead here like this. This velocity is a vector quantity, so I put the arrowhead like that. Now similarly, we also have acceleration, that is a equal to v by t. So we measure this in the units, that is meter per second square. Okay, so this is what acceleration. So these are the different units we use. Okay, different units we use for this. Okay, so you know this about the different units, right? So we use this meter per second. Okay, one more conversion we know, that is if you're converting for velocity and speed, there's a conversion also. You should remember this: 1 kilometer per hour. If you're converting into meter per second, so we just take and divide this, because 1 kilometer is equals to 1,000 meter, and 1 hour is equals to 60 into 60, that is equals to 3,600. So that will be equals to we just take 1,000 divided by 3,600. So 0 0 gets cancelled. 10 by 36, this is 5, this is 1 and 8. Okay, so 5 by 18 we get. So 1 kilometer per hour. Okay, can you able to see this? Otherwise I'll put here. So just remember, 1 kilometer per hour can be taken as 5 by 18 meter per second. Similarly, one, that is meter per second, that is equals to 18 by 5 kilometer per hour. That's a reciprocal value we take for this. So this is the conversion values. Okay, so you can just remember this also. Distance, displacement, measured in meters. Okay, both are measured in meters. Velocity and time, both are measured in meter per second. Acceleration is measured in meter per second squared. And one more thing, if you take the g value, that is how much we get, 9.8 meter per second squared. Okay, the g value is 9.8 meter per second squared. 1 kg weight, you know, if you study this, 1 kg weight, that is equals to how much? 9.8 newtons it is. Okay, so those simple values we have, right? So this this can also be taken as approximately equal to 10 newtons. Okay, 10 newtons. G value can also be equal to 10 newtons sometimes. Okay, because G is what? Acceleration due to gravity, force is measured in newtons. So 9.8 newtons can also be taken as, you can say right here, 10 newtons. Okay, otherwise you can write this one. Okay, in this way, 9.8 newtons can be written as 10 newtons also some of the times when you're doing any kind of a calculation part. Okay, so that time also we use this. And we have equations of motion, right? Three equations of motion we have. What is the three equation of motion? We have V equal to u plus at, s is equals to ut plus half at square, and v square minus u square is equals to 2as. These are three equations we have. And these three equations we're going to derive how we get these equations, and then we do some numerical part related to this in the kinematics. That's the end of the chapter. Okay, so that's the last topic we have. So this is the last topic we have. We'll see how we get these equations, and we use this to solve different numericals. Okay, based on this, you have a lot of other questions which will ask you to find out velocity, acceleration, displacement, all those things will be asking you to find out. So how we get this equation, we will derive that, and then we will see how we can solve the numerical part. But before this one we have done, and before this we have one more topic, that is graphs, which actually we are trying to discuss today. Okay, so this is the basic things behind the graphs. Now we will see the first graph now, for graphical representation for VT graph. What is VT? Velocity time graph. So we're going to check here what is there on the x-axis and what is there on the y-axis. Okay. So here, if the object is at, if the object, the first case is, if the object is moving with constant velocity. Okay, constant velocity. If the object is moving with constant velocity, what happens? Let's see here, if the object is moving with constant velocity, then what happens? It will be moving in a, for example, let us take 60, 50 or 60 kilometer per hour. So first hour, second hour, third hour, and fourth hour, the object is in the same position. Okay, otherwise I'll just draw it in clearly I'll draw, you can see here. Okay, independent quantity, dependent quantity. Independent quantity is time here, and dependent quantity is velocity here. Okay, you just write as v. So this is the velocity, we measure in meter per second. You're supposed to write the units also there in there. This is x-axis, this is y-axis. Okay, here we are taking time in hours, so time here not taking seconds, we are taking hour, and here we're taking kilometer per hour. Let us take, this is 1 hour. Okay, like this we go on. Now here we have on the y-axis, this is 1 hour, this is 2 hours, 3 hours, 4 hours, and 5 hours. Here we have, let us take 10 meters, 10 kilometers, 20 kilometers, 30 kilometers, 40 kilometers. Okay, now let us take the object is moving with constant velocity with 40 meter per second square. Okay, or kilometer per hour. So 40 kilometer per hour it is moving. Let us take. So here it is 40. At zero it is 40. Sorry, at this point it is 40. With the first hour it is 40. Second hour is also 40. Third hour is also 40. Fourth hour is also 40. Fifth is also 40. That means it is maintaining a constant speed. So if the object maintains a constant speed like this, okay, if the object maintains a constant speed like this, so we say object is moving with a constant speed. For this we get a straight line graph parallel to the x-axis. So the graph will be just like this, straight line that is parallel to the x-axis. So here this is velocity, this is time, the graph will be represented like this. Okay, the graph will be represented like this. So this graph shows that the object is moving with, a constant velocity parallel to the x-axis, and the graph which you got here is a straight line parallel to the x-axis. We get a straight line parallel to the x-axis, and this graph, velocity time graph, for a straight line graph like this which is parallel to the x-axis, we call them as the object is moving with constant velocity. Okay, so this is a constant velocity graph. So we get a graph like this. This is the graph. For every 1 hour, the object is in the same moving with same velocity. The velocity is 40 kilometer per hour. This never changes the velocity here in this case, so it will remain constant. So this is called object is moving with constant velocity. Okay, there is neither increasing neither decreasing the speed, it remains constant. So this kind of a object, we say that object is moving with constant velocity, or it's also called as uniform velocity. Okay, the object is moving with uniform velocity. For uniform velocity, we get a straight line graph which is parallel to the x-axis. Okay, a straight line graph which is parallel to the x-axis. This is called uniform velocity. Now let's see the next one, the second graph. We'll check here. Now, we'll try to check here the second graph, which talks about if the object moves with increasing, that is velocity, that is uniform accelerated motion. For an object which is moving with uniform accelerated, how it will be moving. We'll see here. And we try to take two axes, x and y. Okay, in x-axis we take time, and in y-axis we take velocity. Okay, here let us take time, one, two, third second, fourth second, and fifth second. Time is measured in seconds here, and meter per second is the velocity is measured here. Now let's the value of velocity is, let's take 2, 4, 6, 8, and 10. This is the velocities. Now with respect to this data which is given here, we'll try to find out case number 2. What is the case number 2? Moving with accelerated, uniform accelerated motion. So the second is uniform accelerated motion. So if you're talking about this uniform accelerated motion, what happens in this? We take two axes, x-axis and y-axis. Okay, here we take time in the x-axis, and here we just take y-axis or velocity. So the velocity will be in the y-axis, meter per second, and the values we're going to take here is above the table. So here we have took the table. With respect to this table, we'll see 2, 4, 6, 8, and 10. It is 1, 2, 3, 4, and 5. Fifth second. Now, time in the x-axis. First hour or first second, the object is traveled up 2 meters per second. And the next second, the object is traveled to 3. That is 4 meters per second. In the next third one, it is traveled to 6 meters. So third one is traveled to 6 meters. So this is the thing. Fourth, it is traveled to this one. Okay. It is traveled to this one, and the fifth one is traveled to this one. It is traveled to 10. So 5, 10. So here it is 5 and it is 10 here. Okay. So we get a graph, this is a straight line graph like this. You can see here. Okay, this is a graph we got for uniform accelerated motion. A straight line graph passing through origin. Okay, a straight line graph which is passing through origin, we call them as object is moving with uniform accelerated motion. So uniform accelerated motion, we see here a graph which is passing through origin, a straight line graph we got which is passing through origin. And what does it shows? It shows that as this increases, this also increases. It means as at every 1 second, the object is moving with 2, 4, 6. So for this graph, if you take any 2 points here, A and B, we'll get these 2 points and attach this at this point. The point C, there is nothing but slope. We can able to find out the slope for this graph. So here, two axes, vertical as well as horizontal. This is the horizontal lines I'm taking here. Okay, vertical lines as well as horizontal lines both we take, and we'll try to find out the this. That is point C. That is slope. Slope is also what? That is y-intercept divided by x-intercept. So here y-intercept here is 4, and here it is 8. Okay, so what is this? This is v2. This is v1. Okay, and here it is t1, this is time t1, this is time t2. So y intercept is this and x intercepts are this. So v2 minus v1 final velocity minus initial velocity, that is for 8 minus 4. Okay, and here time is t2 minus t1 final time minus initial time. Okay, so v2 minus v1 by t2 minus t1. So 4 minus 2, here it is minus 4. 8 minus 4 divided by 4 minus 2. So what you will get here? 8 minus 4 means 4 divided by 4 minus 2 is how much? that is 2. So 200 2 2 ja. So the acceleration is 2 meter per second square. So we get here, with respect to the slope, we get acceleration. Okay, with respect to the a, we got acceleration here. Okay, so we are finding what? We are finding the acceleration in this graph. So acceleration can be determined with the help of this slope. Yesterday we have seen a graph which is just like similar to this, but there we have find out the, with the help of the slope we determine the velocity. But here we are determining the acceleration because it's a velocity time graph. So velocity by time, y-axis is velocity, x-axis is time. So y by x, velocity by time, that is nothing but acceleration. So the gradient of this graph, you can say the gradient or the slope of this graph will give you the information of acceleration. So this is important. So it will give the information of acceleration. So acceleration of an object can be determined with the help of this graph. So this is the second type of graph which we are seeing here. Okay, slope will give you the information of acceleration of an object. Is it clear? Yes. Any questions here? You can ask me.
No questions.
Right? Is it clear? Right? Okay. Now, let's see the next one, the third graph. So the first graph, I hope you have written. Second graph also you can note down this. You want to note down? It's okay, no? I think you know about these graphs most probably. Do you want me to keep it here or rub it? Shall I rub? Yes.
Yes, sir.
Okay. Now, next, third category of graph. Here we have third, number 3. What happens if an object, here we've seen first case, object is moving at constant speed. And the second case, we have seen object is moving with a uniform accelerated motion. And the third, we're going to check here, what happens to the, when the object is deaccelerating. Okay, so the time deacceleration, a graph which is showing for deaccelerated, uniform deaccelerated motion. Uniform deaccelerated motion. So what is uniform deaccelerated motion? We'll see here now with the help of this graph. Now you can see if the object moves in the downward direction like this, here velocity and time we're taking. Okay, it is taken in meter per second, time is taken in seconds. So if a graph we got here like this, some points on the graph, and it's continuously decreasing to 0. Okay, so this kind of a graphs we generally call as deaccelerated motion. So what happens here, the acceleration will be negative value because it's continuously decreasing. For example, here it is 10, it is 8, it is 6, it is 4, it is 2, here it is 0. Here 1, 2, 3 and 4 values here we have. And these points, if you see here, this is meeting at the point, these points. Okay, so this is a point they are meeting at. Okay, right. So here we have different points on the graph. So like this, we get the graph. So here, similarly, we also have in the y-axis, if you check, like this, we have. So this is a deaccelerated motion. Okay, deaccelerated motion object. So we can see here what happens. The object continuously decreases to 0. After some time, you'll see the object comes to 0. Acceleration will be equal to 0. So this is a deaccelerated motion. So when the object is moving with a deaccelerated motion, we'll draw like this. So velocity time graph when the object is deaccelerated motion. And the fourth case here we have, what the fourth case means, if you take an object which is, you know, moving with different speed, it's never have the same speed at a time. It continuously changes its speed. For example, it is 2, again test 10, it's reached 20, it's 50, 80. The graph for this, for 1 hour, 1 second, okay, I'll just draw this graph. Here you can see the speed is changes continuously. If you take an x and y axis, let's draw the table. So here it is time we're taking on the x-axis, measured in seconds. Okay, this is 1, 2. Okay, let's draw this. 2, this is 3, this is 4, this is 5, this is 6. Okay, this is 3, 4, 5 and 6. So we draw this table like this. Okay, can you able to see this? No, this part you cannot see at the bottom. So I just draw this graph and see here when the object moves. Here it is 1 second is 20. It's moving with somewhere it is, you know, like this. It's moving in a different speed here. Then it is increasing the speed. Suppose after this time here, let us consider 20. It has reached to after 20 it is reached to 25, 30. Like this it goes on. Again after some time it is decreased. Okay, again it has increased like this. If you get a graph like this, okay, like this, if you get a graph, this is a decelerated motion. So if you're getting like this, one more point here, so it's a decelerated motion. So there is uniform decelerated motion. So we can say it's a non-uniform motion. Non-uniform accelerated motion. Non-uniform, okay, non-uniform accelerated motion. So this is the fourth category of graph where the object speed doesn't changes, continuously changes from peak to downward. So it increases as well as decreases, again increases, again decreases. So this kind of graph we say that the object is moving with decelerated motion. Okay. This is the fourth category of the graph we have. So now after this we have the fifth category. What is the fifth category of graph? That is a special case where the object is initially not moving from rest. It is moving with certain velocity. So for that we will see a special kind of graph. You can see here on the board. If the object is initially not at rest, that is not at zero, it is moving with some certain velocity like 2, 4, 6, starting with 2. So we get a straight line graph after this. So we get a graph like this. So this kind of a graph we say as fifth category of graph where it talks about the object is moves with this object is moving, you know, but it's not at rest. Initially, it's not at rest. So uniform accelerated motion, but the object is not at rest. Okay, because it's not at rest, it's not starting from zero, it is starting with certain velocity. That means already it is in motion. So if the object is already in motion, if the object is already in motion, so we say that it's moving with certain velocity initially. So initially the object is yet not at rest. Please note down this point. This special case, fifth category of graph. Here we have initially when the object is not at rest. Initially, when the object when the object is not at rest. Okay, this is an important point here. Not at rest. Initially, the object is not at rest. So that means it is already having certain velocity with it. So with which it is moving. So this type of graph which you're getting here, this is we say the object initially is not at rest. Okay, so this kind of graphs we just see in a special cases where we, with the help of these graphs, we will try to find out the equations of motions, different equations of motions we will get. So that we will discuss with respect to this graph. So when the object doesn't move with from doesn't start with the velocity, then it is initially is not at rest. So for this we get a graph like this. So we have total 5 different type of graphs which I have drawn here. Okay, so what is that 5 types of graphs which are drawn? Okay, the first one here we have seen the graph is just like this straight line. The second is, this is the second graph. Okay, and third graph you have seen here. Okay, third and fourth is given here. Okay, it's like this. Sorry, this is decelerated motion, and the fifth one is this. So 1, 2, 3, 4, and this is the fifth one. This is the fifth one. So fifth graph will be just like this. It's not straight line, it's just moving in a different direction. So this is the graph 5. So we have graph 1, this is 1, this is 2, okay, this is 3, here we have, and this is 4, and this is fifth. Total 5 graphs we have. Okay, this first, this second, this is third, this is the fourth, and this is the fifth one. Okay, so this is all about the graphs. So 5 different graphs we have seen, and here in all these graphs we have seen one important thing that object is moving with initially at rest. Okay, sorry, when the object is moving with constant velocity, we get the graph like this. If the object is moving with uniform accelerated motion, we get like this. And with the help of uniform accelerated motion, with the help of the slope, we can determine the acceleration of the object. And the third is decelerated motion. This is a decelerated motion. And the fourth one is if the object is moving with non-uniform accelerated motion. So this is a graph for this. And the fifth one, if the object is initially is not at rest, then we draw the graph like this. That means initially it's not starting from zero, it is starting with some velocity. Okay, so this is the five different types of graph we have done. So when you come back to school again, then we will discuss the equations of motions in the next class. Okay, so have a nice day till that time, and meet you soon. Thank you so much. Shall I log out? Yeah, everybody, you can just log out, then I'll log out here.